gotta make it better. All right. So 5, 6, Doug. So 5, 6 is definite integrals. Okay, so 5, 5 was indefinite integrals, and 5, 6 is definite integrals. Okay, so right here there's a quick notation for a definite integral. What looks different to you compared to the indefinite? Okay, the B and the A. So basically what is happening is now these A and B are basically x values that are going to bound our function. Okay, so we're only looking between the x value. A is going to be the lower x value. Okay, and B is going to be the upper x value. Okay, so the idea, they use this this phrase of signed area. Okay, so the idea is if you have a function, let's say we have this crazy function that exists right here. Okay, and we say we're going to bound it between the x values of -1, let's say that's -1, and +2. It binds the area between these two x values, the function, and the x-axis. Okay, so definite integration finds area underneath a curve. Okay, so I'm going to show you 3 ways to do that. I'm going to show you how to do it on the TI-84. I'm going to show you how to do it on the Inspire. And I'm going to show you how to do it by hand. Okay, because of course there's non-calculator parts on the test that you have to know how to do it on by hand.
Are we doing all the notes today?
Yep, we're going to do all of them today. Alright, so everybody grab your 84. We're going to start by doing this on the, the 84, and I'm going to start by doing this graphically. Let's see if it lets me turn on the calculator. Alright, so the first thing that we're going to do is we're going to start by graphing these functions. Okay, so go into your y equals. Okay, and I want you to start by just putting the function into the y equals. So we got x to the third minus 6x. Okay, then hit zoom 6 so you have a standard 10 by 10. You should see a John Travolta. Everybody there? X cubed minus 6x. Okay, so what we can have the calculator do is figure out what the area is between -3 and 1 by hitting second calc. And then we're going to go down to number 7. See how it has that integral notation? And immediately it asks us for the lower limit. Okay, so the lower limit is going to be the lower number, which in our case is -3. Hit enter, and then I'm going to hit the upper limit, which this one is 1.
Wait, how do you type it?
Where'd you get the -3?
From the integral, see on question number 1.
What do we type in after we graph?
Syntax error. Did you get to the function part?
Wait, is it -1?
You must have done it back. No, -3 to +1. Do you guys see where I'm getting my function? Look at question number 1.
Yeah, where do we go for what one is this lower limit?
-3. Lower limit is -3. The upper limit is +1.
How do you know it's
Because look at question number 1. You see where I'm looking?
Do I go below -3?
No, just type the number. Like type it. Just push in the number. You don't have to use arrows.
And then what do I do now?
Hit enter. What if I don't know where you're at?
It says upper limit.
Okay, the upper limit is 1.
Now I jack it. Okay, yeah, I'll do it again.
Second. Number 7. Now type -3. Enter. 1. 1. Enter. Good job.
Where'd you get it? Oh,
Yeah, that's all you do, right? Okay, so everybody get a 4. Okay, so that means that the area, the shaded area, is 4. Okay, now one thing that you need to understand, actually I'm going to show you this on the next example. Okay, so let's do question number 2. Okay, type in question number 2. We have the exact same function. This time we're looking between a -square root of 6 and a +square root of 6. So hit second trace, And we're going to do number 7. Okay, the lower limit is negative square roots of 6. Upper is a positive square root of 6. Okay, what is the area for this particular scenario? 0. How does it make sense that that shaded region has an area of 0?
They cancel each other out.
Good. Okay, so what you need to understand is that area that exists above the x-axis is a positive area. Area that exists below the x-axis is negative. Okay, so there was exactly the same amount of positive as negative area in this scenario. Okay, so for question number 3, we need to go back and readjust our function because now they have the absolute value. Okay, so go back to the y equals. This time you're going to insert absolute value. There's 2 ways to do that, by the way. You can hit math and go to number. I'm going to hit abs. Or you can hit alpha window, and it's the first option. So I'm going to insert a abs personally. Oh, just kidding. I thought that would work. X to the third minus 6x.
That's a great
Okay, so yeah, you should know before we hit graph that absolute value just reflects everything over the x-axis, right? Okay, so question to you. Does this actually touch the x-axis?
No. No, that's not.
Yeah, it does. Okay, absolute value actually does touch the x-axis. Okay, so what's happening on our 84 calculator is that the pixels are not allowing the calculator to go down and touch it. Okay, so it doesn't appear to touch the x-axis in this frame, but if you did zoom in, you would be able to see that it does actually, in fact, touch the x-axis. Okay, so we can go ahead and find the integral from -5 to +5. So I hit second calc. I choose number 7. I go from -5, enter, to +5, enter. Ooh, this must be a big area. It's taking some time. And there it is. So 198.501. Did anybody else get that?
Yeah.
198.501. Did everybody get that, or if you might have done it backwards, Tyler? You might have done 5 to -5 by accident. Make sure that you have lower is your lower number. -5 to +5. Yep.
It says error invalid.
Why do we need to learn it the other way?
Yeah, negative key. Yep. Not the minus.
Wait, I think, hold on, maybe it's my Zoom. Zoomed out, right?
Oh, because you're zoomed in. Maybe because you did zoom in. That's possible.
Okay, yeah.
That worked? All right. So that is how you find the okay, so that's how you find integrals on the 84. You can also find the integrals on the 84 in the home screen, just so you know. Okay, if you hit second quit and go back to the home screen, to get this integral notation, you have to hit alpha, is it zoom? Nope, sorry, alpha window. There it is. Okay, so if you hit alpha window, you can find the number 4 function integral. Okay, and that sets up the exact notation for a definite integral. Okay, so just be aware that 84 will not integrate an indefinite integral. You have to have a bound for the 84. Okay, alpha window number 4.
Wait, the TA84
Won't do indefinite.
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 Number 4?
Right.
Is that what we're typing in?
Well, you can type it in that way if you want. Because you can check it out and see if you get the same answer. Let's just do it.
How do you do absolute value?
Alpha window, first option. Did you get something different? Just barely though, right?
That's the same thing.
Pretty much.
I got 4. So are those arms that were on the graph, are those going up to like a vertical asymptote or something? Because
No.
with the area it's increasing.
It would be increasing, yeah. So no, it's not an asymptote. It's not an because if you were bounding on an asymptote, it would be an unboundable area.
They tell you that?
Yeah, you know, I'm not sure. I never tried it. I don't think you could find an integral that had an asymptote in the middle of your region. I don't think it'd be possible. Okay, so let me show you how to do this on the Inspire real quick. So grab your Inspire. I have one extra one right here. Oh, well, there's still one right there. Okay, so on the Inspire, you guys will just have to maybe write this down, or maybe one of these guys would let you borrow. Or there's one right here. Oh, good. All right, so to find the integral on the Inspire, you're gonna hit menu. I bet you might be able to figure this out on your own. You hit menu, you go to calculus, okay, and you just choose number 3. Oh. What? Let's try that again. Your semester ones? I'll probably give them to you on.
Actually, I want to make sure you're kind of mad at me that day.
Oh, really? So you're blaming me for that low grade? Oh.
How do you absolute value?
Absolute value on this thing,
You click that little button by the map.
yeah, on your grade calculator, you have to hit Control and then it's the plus sign. What's that? Oh, on that? Oh.
Can you leave it as like that, or do you have to divide it by 2?
What's that?
It gives you 397 divided by 2, so do you divide that?
Oh my gosh.
Or
Yeah, so then you go to second, or no, you go to menu and then you go to number and convert it. Sorry, I'm not. See the little, you see where my cursor is? Oh, if you hit, what color do you have? You have to hit Control plus. Control plus. I don't know.
My words would hurt you emotionally and like they would hurt you so bad. Rebecca, trust me, my sticks. I was just gonna say.
Yeah.
That you don't understand anything?
Oh my god.
I just have the wrong opinion on every question.
Opinion. Uh-huh. All right, was everybody successful finding the integral on the Inspire?
yes.
Okay.
Can we just skip doing it by hand?
No. That's going to be a problem for you if you can't do this by hand. Okay, so the second way to do this. So there's one way is on the calculator. The second way is using signed area.
How do we do that?
I'll show you if they. Hold on, I can't control this. You got a surface? Nice. Nice. You should set it up with this.
No, I know.
and the area of your object. Okay, so if I draw the absolute value of 2x minus 1, okay, so we know that 2x minus 1 is a linear function, and it crosses at -1. Okay, so I'll just draw the -1. I'll just draw normal 2x minus 1. Okay, and then it would have a slope of 2, right? So you go up 2 over 1. So it's going to cross the x-axis exactly at 1/2. Okay, and then I look over at my integral and I see that I need to go from 0 to 3, so I need to go all the way over to 3. So this would continue upwards. That's a very straight line. Okay, so now if I think about the absolute value of that, I need to take that little piece that's below the x-axis and reflect it up. Okay, so it's going to look like that. So it looks like a V. Okay.
How are we doing this?
Just graphing it. Okay, so now if I bind my function between 0 and 3 and the x-axis, what two shapes emerge? Two triangles. Okay, so in order to do this signed area, I need to know how to find the area of a triangle. Okay, so how do you find the area of a triangle? 1/2 base times height. So let's start with the little tiny triangle. Okay, so the little tiny one is 1/2 times, what's the base? 1/2. What's the height? 1. Okay, and then if we look at the bigger one, we have 1/2 times the base. What's the base? 2.5. I'm going to say 5/2 because I'm already dealing with fractions. What's my height of my triangle? How am I going to figure out how high that goes? Plug it in. So if I plug 3 back into my function, 2 times 3 is 6. 6 minus 1 is 5. So this point up here is 3, 5. So now I know the height of my triangle is 5. Okay, so if I simplify that, I get 1/4 plus 25/4, which is 26/4, which can be reduced to 13/2, or you might call that 6.5. So either of those two scenarios. You cannot do it geometrically with a curved line. You could do it with a perfect circle if you had a circle. It was like a function like this one right here. You can't do that geometrically. You have to use calculus in order to figure that out. So you couldn't use the signed area method. Okay, question number 6. Question number 6 is just asking you to set up the integral. Okay, so it says we're going to use this function x or 2x squared minus 3x plus 2. It's going to be bounded by the x-axis and the x values of 0 and 2. Okay, so what is my integral going to look like? The integral between 0 and 2 of the function 2x squared minus 3x plus 2 dx. That's it, okay? So that's all they wanted you to do in this particular question, is just simply set it up, just so you understand the notation, what you're exactly doing, what you're finding. Easy there? You know what would be helpful there, Tanner, is writing this down. Just a suggestion. All right, number 7. So this one is going to help us figure out the fundamental theorem of calculus, which you haven't seen the formula for yet, but I think we're kind of getting there. Okay, so first of all, they say find the area under the curve of our function, which they're calling the derivative of f, between 0 and 5. Okay, so if I find the area underneath this line, it turns into a very nice shape, which is a rectangle. How do I find the area of a rectangle? What? So how do you find the area of a rectangle?
Like squared.
Okay, so what's my length? 5 times my height, 3, so my area, 15. All right, so now what they want us to do is try to figure out how to do this algebraically or calculusly. What's my function if I have a horizontal line that's at 3?
Y equals 3.
Y equals 3. So my function, my derivative function, is simply 3. Okay, so what they ask us to do on C, or yeah, question C, is to figure out what our original function is. Okay, so if we're given the derivative and we need to find the original, what are we going to do? Okay, good, we're going to find the integral. Okay, so what is the integral of 3? 3x. And then what do I need to add on the ends? Plus c. Okay, so now what are we going to do with that extra information that they gave it to us? The 1 and the 4.
0 into x and 5x.
Good. Okay, so we're going to find c. So 4 is going to be our f of x. We're going to plug 1 into the x, and that allows us to find c. So is everybody good with c is 1?
Yep.
So therefore, our function is 3x plus 1. Okay, so now for question D, they say, what is f of 5 minus f of 0? So let's start by finding f of 5. If I plug in 5 into that function, let's see, that would be 15 plus 1, so 16. If I plug in 0, I would get 1. So what is 16 minus 1? 15. What do you notice about this? It's the same, right? Okay. Yep, the upper bound and the lower bound, exactly. Yep. Okay, so what this is it's giving us the fundamental theorem of calculus. Finding the integral between two x values is finding the area underneath the curve. Okay, very fancy. All right, let's do one more of these. Number 8. Okay, the first thing they asked me to do is figure out and find the area underneath the curve. Now this one is a little different because notice that some of this line exists below the x-axis. So what does that tell me about that area? It's a negative space. Okay, so if I start with that upside down triangle, I'm going to start by saying negative, and then the area of a triangle is 1/2 times the base. What's the base of this triangle? 1 times the height? 2. Okay, and then my triangle above is positive, so I'm going to add 1/2 times the base. It's 2 times the height, which is 4. So we get -1 plus 4, right? So we get a total area of 3. Everybody agree with that? Get my math right? Okay. For B, what is my equation? What is my derivative equation? Okay, so it has a y-intercept of 2, a slope of 2. Yep, I would agree with that. 2x plus 2. Okay, so now we're going to figure out what the original function is by integrating. So what's the integral of 2x? X squared, nice. What's the integral of 2? 2x, and then we say plus c. Now we're going to use our point, plug it in, so we have 0 is equal to 1 squared plus 2 times 1 plus c. So 1 plus 2 plus c. C makes -3. Everybody follow that? So we get x squared plus 2x minus 3 for our function. Okay, so now if we plug 1 into the function, we can probably do that mentally. That would be 1 plus 2 minus 3. That's 0. That was actually given to us in C. I just realized. If we plug in negative 2, let's see, that would be 4 minus 4, which is 0, 0 minus 3, negative 3. Okay, so we get 0 minus negative 3. So what is our area from the original function? Okay, which does agree with what we got for A. Okay, so that is exactly what we're going to do. Okay, oh, they still give us one more.
Yeah, it goes all the way to like 14.
Well, I didn't want to keep going with this. I want to go through.
Let's call it.
We're not going to stop there yet.
It's getting pretty late.
Let's stop there.
Oh, okay. No, we're good. Okay, so let's keep going. Question number 9. This is actually a good point that they make on this question. Okay, so if they're finding placement, how do you find displacement? You subtract. So it's, you plug it in, so you do the bigger one minus the smaller one, right? Bigger minus smaller. So if I plug in 4, can we do that mentally? 4 squared is 16, divided by negative 2 is negative 8. 8. So did anybody else get 5? Is that right? Will somebody double check that? Let's see. We got 16, negative 8. Into the original. So, yeah, the 1/2. So negative, let's see, we got 16, negative 8 plus 16 is positive 8. Yeah, I'm still going 5. I feel pretty good about 5. Minus. If I plug in 1, I get 1/2 plus 4, which is 3.5 minus 3, so I get 1/2. So 4.5 for that, for displacement. How do you find velocity given the position function? Derivative. So what's the derivative? Negative t plus 4. Okay, so then it says to graph that. So I would start with a y-intercept of 4, a slope of negative 1, which is going to hit my x-intercept at positive 4, right? I go down 1 over 1. Okay, so then it says find the area between 1 and 4. 1 and 4, so that's again a triangle. We need to figure out what this height is. What is that height at 1? 3. So 1, 3. 1/2 times 3 times 3, right? Which is 9/2, also known as 4.5. Okay. Huh. That is cool. How it works? Sir Calculus. Okay, so here is the fundamental theorem of calculus. Okay, so this is what we are going to do it by hand. Okay, so you're going to find the integral, and then you just simply plug in the bigger one minus the smaller one. Exactly what we just did.
What? Bigger one minus the smaller one, or is the top one?
Same thing. Yes.
Oh, really? Is the bigger one always on top?
Yeah. All right, here we go. Are we ready? By hands? Focused? Do we need a break? Do you guys need to take a break?
I thought we were going to. Yeah, you said this was the last question, like 2 questions ago.
No, I didn't. The last question like that.
I don't understand.
This is method 3, doing it by hand without a calculator. I'm not surprised. Okay, so first question, number 10. The first thing I want to do is rewrite this. I don't like the way it has a square root. Okay, so I'm going to have 2y to the 1/2 plus 1. Okay, so the next thing I'm going to do is I'm going to integrate my function. What is the integral of 2y to the 1/2?
3/2.
Good. So if I divide by 3/2, that's the same as multiplying by 2/3. So if I already have a 2 there, can you guys do this mentally? If I have a 2 there, it's going to be 4/3 y to the 3/2. Okay. What's the integral of 1? 3/2. So because you add you add one to the 1/2, right? So 1/2 plus 1 is 3/2. If you divide by 3/2, that's the same as multiplying by 2/3. 2/3, the reciprocal. You're just comical today. Alright, so once I have the integral, what do I do next? Bigger minus smaller. Okay, so I just plug it in. Okay, so you do 4/3, 4 to the 3/2 plus 4, minus, and then you plug in 0. Okay, so if you do 4/3 to the 3/2, that's 2 cubed is 8. 8 times 4 is 32/3 plus 4. And then, let's see, we got minus 0 at the end, right? So 12 and 32 is what, 44 thirds. Everybody good with that one? Yeah, you could rewrite it. I would just leave it that way though, personally. All right, question number 11. Which rule do we have to do to integrate this?
Fundamental theorem of calculus.
Which rule do we have to use to do the integral?
Usubstitution.
Closer.
Just
Just the general power rule. Yep. Okay, because if you take the derivative of the inside, what's the derivative of 4t? 4, and there's no t involved, so we're okay. Drink like pop? Because it's illegal there. That's pretty good.
Okay.
I think I have an answer now.
So we're not done yet. Are we ready? Can we continue?
What is that line? What is the line that has the A, B, and the A? Agreed.
Oh, that's just the notation, which means I've taken the integral, but I haven't plugged the numbers in yet. That's all it means. It means this is the integral of the function that I just took, but I still have to plug those values in.
Okay. Just remind. And is that a 4?
That you're just not finished. Yeah, you're not done yet. You can't get rid of that notation.
24.
Okay, so there's kind of two ways that you can do this. See how you got 24 on the bottom? What I'm going to do is I'm going to pull the 24 out, and since it's on the bottom, I'm going to technically pull out 1/24. Okay, which means now that I have 4t plus 1 to the 6th power left, and that's what I'm going to plug in. Whoops. Okay, so now I'm going to do bigger minus smaller. I'm going to use brackets because it looks better. So 4 times 1 plus 1 to the 6th power minus 4 times 0 plus 1 to the 6th power.
What is going on?
I'm plugging in the bigger minus the smaller. You could. Absolutely you could. But I would prefer to deal with smaller fractions than more complicated ones.
She way up at the top, 4t plus 1 to the 5th, she integrated that.
Yeah, but, okay. And then you just pulled out.
Yeah, I pulled it out. So what's 5 to the 6? Can somebody type that in the calculator for me, please?
Okay, so that's like
5, 6. 1, 5,
5 to the 6th. What?
Are we 1, 5, 6, 5?
1, 5, 6, 2. So I'm going to say 4 because I'm going to subtract 1. Okay, divide that by 24 for me, please.
Is there any reason you put brackets?
651.
But do 1, 5, 6, 2, 4 minus 24. Because it just looks nicer, I think. See what I got there? 1. 651. Wait, it should be exact. It should be exactly 651. You forgot to subtract 1. 24, not 25. Because see how I have minus 1 to the 6th there? Alright, so I would like to do this last question. Do you guys, are you ready? Can I do one more question?
Substitution.
This will be the last one. It is a U substitution question. One more. Last one. Buck up. Look it in the face. Let's just do it.
Oh, wait.
Okay, so for question number 12, I have to do the U substitution. The very first thing that I'm going to do is rewrite it and bring that quantity that's in the bottom up. So I have 2x minus 1 to the negative 1/2. Okay, the next thing that I need to do is identify my U. What is my U?
2x minus 1.
Good. So after I identify my U, I need to figure out what the x value is. So if I solve for x there, what is x going to equal? U plus 1 over 2, which by the way is the same as 1/2 U plus 1/2, right? Okay, and that form is going to be helpful because my next step is to derive that. So my derivative of x is dx. What is the derivative of 1/2 U? Close. 1/2 du. All right, so now here comes the part where I substitute all of the blue stuff into that green equation. Okay, so I have the integral from 1 to 5. X is equivalent to U plus 1 over 2. I have my U right there, so I have U to the negative 1/2. And dx is equivalent to 1/2 du. Okay, so now here comes the part that people seem to be struggling with. It's just simply putting this into standard form. Okay, does everybody see that I have a 1/2 that is in front of the du? I'm going to pull that 1/2 in front of my integral. I am also, you do not have to, but I'm going to because I think it's simpler. Okay, I am also going to pull out the 1/2 from the quantity of 1 plus u, or excuse me, I said that backwards, u plus 1. Do you see that 1/2? So if I pull out 1/2 and another 1/2, what do I have in the front? 1/4. Okay, so I have a 1/4 in front, and what I have left is u plus 1 and u to the negative 1/2 du. Good there? Okay, so now I need to put this into standard form. I'm going to distribute the u to the negative 1/2 into that quantity. So that's going to be u to the, what's 1 minus 1/2? 1/2. And 1 times u to the negative 1/2 is u to the negative 1/2. Okay, so now at this point I'm going to integrate my u. Okay, I still have this 1/4 out. I'm not going to touch it. What is the integral of u to the 1/2? So it'd be u to the 3/2 divided by 3/2. So if I 2/3 u to the 3/2, which is the same as what you just said. Okay, if I integrate u to the -1/2, that would be u to the +1/2 over 1/2. What happens if you divide by 1/2? 2u to the 1/2. Okay, I technically need to say, I still need to plug these in. Okay, now the next step, before I plug my 5 and 1 in, and remember those are in terms of x. Right now I'm in terms of u, so what do I need to do? I just keep it out there. It's going to be the very last thing that I do. Okay, good. So I'm going to plug that in. So I'm going to have 2/3, 2x minus 1 to the 3/2, 2x minus 1 to the 1/2. I still have to plug that in. Okay, everybody good with there? Just plugging it back in. Okay, so now I have to do big minus little. Okay, so I'm going to plug in the 5 and the 1. I'm going to still leave this 1/4 way out front. I'm not touching it. So we're going to have 2/3, 2 times 5 minus 1 to the 3/2 plus 2 to the 1/2. And then I'm going to subtract plugging 1 in. Okay. Whoa. All right, so now I'm just going to simplify everything on the inside. Okay, this actually turns out pretty nice. So on the first quantity, I have 2 times 5, which is 10. 10 minus 1 is 9. I have the square root of 9, which is 3. 3 to the 3rd is 27. And then I have times 2/3, so 27 divided by 3 is 9. 9 times 2 is 18 for that first number. Okay, so then I have 10 minus 1 is 9. 9 to the 1/2 is 3. 3 times 2 is 6. Then minus. Then I have 2 minus 1 is 1. 1 of the 3/2 is 1. 1 times 2/3 is 2/3. I'm distributing the minus, so my last term is going to be minus. 2 minus 1 is 1. 1 to the 1/2 is 1. 1 times 2 is 2. Okay, so at that point, you can kind of type that in your calculator or do your mental math, and you should get 16/3. Yeah, that one is a doozy.
Oh, I see.
Yep, you can, but if you don't have a calculator, which you will have that on the test, FYI.
So that's the area.
You're gone.
That's the area under the curve. So you guys need to do 1 through 15 for Friday.
We have to do 5, so I just